This video will compose the practice problems and involving metric unit conversion. Please do note that this graph, I'm not sure if it's correct in any specific way, but yeah, we do have practice problems involving units that we have not discussed in the earlier video today. So let me guide you through the process. There are some formulas that you have to know. One, for instance, is that 1 terabyte is equal to 1024 gigabytes. We'll need to have this in mind. So let's highlight it. Here we go. Alright, let's start. With number 1.5, we have to convert 1.5 terabytes to gigabytes. We do have to acknowledge again that 1 terabyte is equal to 1024 gigabytes. And in that sense, we just have to, again, interchange their positions. What's on the right will be on the left and vice versa. And so 1024 gigabytes, that will be equivalent to 1 terabyte. And let's make another fraction. 1 terabyte over 1024 gigabytes. The way we make the second fraction, we just apply reciprocation process in the first one. So we have A, we have B. Choice A and choice B. So right now, we write 1.5 terabytes and our denominator will always be 1. And you multiply it to the fraction that has terabyte in the denominator area, which is this one. So we use choice fraction A. We apply it here, so 1024 gigabytes over 1 terabyte. Actually, let's make this color light gray and cancel the unit terabytes, and 1.5 times 1024, we get 1536 gigabytes. This is the final answer. So as you can see, for the first problem, this table isn't exactly useful as much. I'm not sure why I put it there in the first place. But yeah, I did warn you already that this graph might be inaccurate. I mean, this table. Okay, for number 2, do acknowledge that 1 terabyte is equal to 1024 times 1024 MB or megabyte. So as you can see earlier, from terabyte to gigabyte, they're just 1 0 from each other. So from terabyte, I think the interval is 1024, since this is also something that you have to know. 1 TB is equal to 1024 raised to 2 MB. This is literally the same as this one. 1024 times 1024. It is also, in other words, 1024 raised to 2. So yeah, I think you get I hope you could understand the pattern here. So when from terabyte to gigabyte, we just 1 terabyte is 1024 gigabytes, and 1 terabyte is equal to 1024 raised to 2 megabytes. And if it's kilobyte, it might be 1024 raised to 3, and if it's byte, raised to 4. I hope you understand the sequence. Alright, let's go back to number 2. 1 TB, put this in the calculator. Should your teacher allow you to use calculator in a conversion test, please do make use of the opportunity. So 1,048,576 MB. This is this is our basis. So we put the values in fractions. So 1,048,576 megabytes equal to, just reciprocate them, 1,048,576 megabytes over 1 terabyte. Alright, so let's move on. 1.5 TB over 1, as always. Place over 1 as our denominator and choose which fraction can cancel the unwanted term and bring in the wanted term. Unit, not term. So 1,048,576 MB over 1 terabyte. Dang, I forgot to apply light gray color. Sorry about that. Right, we cancel terabyte, and 1.5 times 1,048,576 MB, it's equal to 1,572,864 megabytes. This is the final answer. Alright, let's move on to number 3. 1.5 terabyte to kilobyte. As stated earlier, from terabyte, if we go down by 1 0, we get 1024, and we get another 1024. So 1 2 1 2 3. It's basically 1 terabyte is equal to 1024 raised to 3 kilobyte. Okay, so let's rewrite that here. 1 TB is equal to 1024 raised to 3 KB. Now, let's translate this form into actual number, which is 10 million. I'm sorry. I'm just going to write the numbers first, excluding the commas. 1073741824 KB. Right? So yeah. It's 1,073,741,824 kilobytes. So we wouldn't have to write the entire whole number for the fraction making process. So we stick with this equation. So 1 TB over 1024 raised to 3 KB is equal to 1024 raised to 3 KB over 1 TB. Okay, so 1.5 terabytes over 1 times 1024 raised to 3 KB over 1 terabyte. So 1.5 times this quantity, our answer is I'm sorry, the number is quite big. Let me write it in let me write the answer number by number. 12736 KB. Okay. I hope this isn't wrong. Please do check it on your own, just in case you're not comfortable with the answers stated here. But I can assure you that these are correct answers. So we get 1,610,000. I'm sorry. This is already in billions. Yeah, it's in billions. 1,610,612,736 kilobytes. That's the final answer. Okay, for number 4. So 1.5 terabytes to bytes. So from terabyte 1, 2, 3, 4. So therefore, 1 TB is equal to 1024 raised to 4 bytes. Let's apply that conclusion. 1 TB is equal to 1024 raised to 4 B. So 1 TB is equal to 1024 raised to 4B, which is also equal to, just reciprocate, 1024 raised to 4B over 1 TB. Now, let's move on to converting. So 1.5 TB over 1 times, this is the chosen fraction. So times 1024 raised to 4B over 1 TB. Okay, cancel the unwanted unit. And so 1.5 terabytes, 1.5 times 1024 raised to 4, our answer is, it's actually in trillions. Let me see, 1,649,267,441,669 bytes. This is the final answer. Oops. There you go. Alright. Let's move to number 5. So from numbers 1 to 4, they're basically questions involving these units. We didn't really pay much attention to petabyte for both good and bad reason. But mostly for good, since this isn't exactly part of our exercise. I'm not sure why. For number 5, let's continue. This time we the units that we studied in the previous video, will be applying that kind of the knowledge that we got there here. So from UG to MG, let's start with CG. So CG, then below we have MG, then 2 values, then we get UG, then 2 values more, we get nanogram. UG, by the way, I'm not sure if this is U, but let's just assume that it's U just for this video. I'm not really familiar with the Greek alphabet, so pardon me. From MG, so 1, 2, 3. We count how many, how much is their distance. So we have 3. What's our value? Zeros. I mean our unit. 3 zeros. So from 45 UG, I'm sorry, from 1 MG, the unit that follows with the number 1 will always be the number above, the unit above. So what's above right now is the milligram. So 1 mg is equal to 1,000, since we have 3 zeros over here. I didn't know about this. Dang. Alright, by the way, anyways, 1,000, our unit is UG, or microgram. Okay, so I will show you the shortcut later. But for now, let's just have a few more exercises involving the long cut. So 1 mg over 1,000 UG is equal to 1,000 UG over 1 mg. Okay, so right now let's start converting. So 45 micrograms over 1 times 1 mg over 1,000 micrograms, or UG. Cancel the microgram unit. So we have 45 over 1,000. You divide both sides both the numerator and denominator with 9. I'm sorry, just 5. We get 9 over 200. And as stated in the previous video also, it is crucial for the answer to be in decimal form, not in fraction form. You wouldn't give a medicine prescription to a nurse or someone who will buy that medicine at a specific pharmacy, a specific medicine that has a unit in fractions. That would be inappropriate. It would be more appropriate if the answer would be, or if the unit, I'm sorry, if the quantity of the medicine prescription would be in decimal form. So translate 9 over 200 in decimal form, you get 0.045 milligrams. Okay, let's move on to number 6. Okay, so 45 milligrams to nanogram. Comparing it to what we have in number 45, the same current value, but this time we'll find nanogram. So let's just copy the values here. Okay, remove what we have here right now. Okay, from UG to NG, you don't need everything there, just this one. So from microgram, 1, 2, 3. The distance between each other is 3 zeros. So our higher unit is the microgram. So 1 higher unit, which is microgram, is equal to 1000, 3 zeros as stated here. Then we enlist the unit nanogram. So 1 microgram over 1000 nanogram is equal to 1000 nanogram over 1 microgram. So with this in mind, let's head over up here. 45 micrograms over 1 times 1000 nanograms over 1 microgram. Cancel the value of micrograms. So 45 times 1000, we get 45,000 nanograms. Okay, so yeah, we still have a few more problems to go through. Let's proceed to number 7. For number 7, from micrograms to, micrograms to kilograms. So kilo, hecto, deca, gram, decigram, centigram, milligram, then 2 values there, then we get microgram. So 1, 2, 3, 4, 5, 6, 7, 8, 9. The distance between each other is 9 zeros. So the higher value, which is in kilogram, which is a kilogram. So 1 kilogram is equal to how many micrograms? 1, then 1, 2, we place 1 here and we count the zeros following it. So 1, 2, 3, 4, 5, 6, 7, 8, 9 micrograms. 1 billion micrograms in other words. So 1 kg is equal to 1 billion UG, which is equal to 1 billion UG over 1 kg. So let's write the 45 micrograms now. 45 over 1 times 1 kg over 1 billion micrograms. Cancel the current values. So 45 over 1 billion is, in scientific notation, it is 4.5 times 10 raised to negative 8 kilograms. This answer is not accepted. We have to remove the parentheses. This isn't algebra, so it's acceptable to use x as a simple form multiplication. So 4.5 times 10 raised to 8 kilograms. That's just what you have to change. As someone who is mostly on, or as someone who is mostly on algebra, it would be difficult to disregard the use of parentheses. So yeah, pardon me if that is if this process is a lot more complicated or longer. Not complicated, but longer by quite a bit. So for bonus, 55 nanometers to kilometers. All right, let's start. Kilometer, hectometer, decameter, meter, decimeter, centimeter, millimeter, then two values, and we get nanometer. Two more values, we get, I'm sorry, this is micrometer, not nanometer. Yeah, and this one is nanometer at the very bottom. Okay, so all the way from kilometer. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I think it's 12 zeros. I am pretty confident that it is 12 zeros in distance. So, what's our higher value? It's in kilometers. 1 kilometer is equal to how many zeros in nanometers? So, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this is in 1 trillion, if I'm not wrong. I hope not. Yeah, 100,000 million, billion, trillion. Alright, 1 trillion nanometers. 1 km over 1 trillion nm is equal to 1 trillion nm over 1 km. Alright, so 55 nanometers over 1 times 1 kilometer over 1 trillion nanometers. We cancel the nanometers unit. 55 over 1 trillion. Let's not write that anymore. We end up having, according to the scientific calculator, it states that it's 5.5 times 10 raised to negative 11 kilometers. The answer could be written this way. It has to be written this way. Or 0. 0.000. You know what? Let's not write the decimal anymore. Let's just write our answer this way. As long as this answer is acceptable, I don't see nothing wrong in adding more possible answers. Since it's really overwhelming to write multiple zeros, you don't know, you might find yourself making mistakes in that sense because of the vast amount of zeros. You might make mistake, and that's a big downfall to your computation. You made the right computations, but you managed to make mistakes in the labeling of the final answer. So yeah, that's what we have to worry about. For number 8, 550 nanometers to kilometers. Again, from nanometers to kilometers, we have 12 zeros. They're just the same with number 7. So 1 km is equal to 1 trillion nanometers. They're practically the same with this one. Let's just copy paste it here. Okay, so 550 nanometers over 1 times what we have, 1 kilometer over 1 trillion nanometer. So we cancel those values. 550 divided by 1 trillion, let's see, it's 5.5 times 10 raised to negative 10 kilometers. So yeah, this is the final answer. Let's move to number 15. I'm sorry, number 9. 15 picoseconds to nanoseconds. This is another value. Let's enlist everything to recall. PS is a very brand new unit. We haven't discussed this in the previous video. We only ended up at the nano suffix unit. So let's write them all. So kiloseconds, hectoseconds, decaseconds, seconds, deciseconds, centiseconds, milliseconds. So skip 2 values, we get microseconds. Skip another 2 values, we get nanoseconds. And skip another 2 values, we get picoseconds. So yeah, that's very long. So long. But yeah, we wouldn't need the rest here. We only need nanoseconds to picoseconds. So how many zeros are they far from each other? 1, 2, 3, or just 3 zeros far from each other. So 1 ns, this is the higher value, so 1 ns is equal to how many ps? 1, 2, 3, 1000 picoseconds. With that in mind, we turn them into fractions. This is what we get, and upon substituting the values now, we get 15 picoseconds over 1 times 1 ns over 1000 ps. Cancel the ps terms. 15 over 1000, 15 over 1000, we get 3 over 200. We divide both the numerator and denominator by 5, and we get 0.015 ns, or nanoseconds. Alright, for number 10, 15 ps to microseconds. Alright, let's start with milliseconds. Milliseconds, 2 values there, we get microseconds, then a few more, then we get nanoseconds, a few more, we get ps. Okay, so from microseconds, 1, 2, 3, 4, 5, 6. We have 6 zeros. This time, by the way, we'll be starting to do the shortcut. We didn't have to do this tedious long process anymore. I'll teach it to you now. So just need some space. Put it there. Okay, there's something that you have to know, which is universal, regardless of what SI unit you are basing your computation from or on. Going up, if your value comes from like a smaller value to a bigger value, going up, you have to divide. Divide what? I'll be telling you later. If you have a value that's bigger and you want it to be, you're looking for it's for the same value in a smaller unit, we multiply. So in that sense, in this case, we are Actually, yeah. We come from picoseconds all the way to microseconds, which is going up, so we divide. What do we divide? Our numerator will always be the current one, which is PS. And our denominator would be the microseconds in, depending on how many zeros it has. So right now we have 6 zeros, so it's 1 million. So 15 divided by 1 million, our answer is 1.5 times 10 raised to negative 5 microseconds, or in other words, US. So this is the final answer. This is the shortcut. It's that fast. But yes, you do have to remember these general um, general ideas. Right? Let's move to number 11. By the way, for number 12, I'm not familiar with these units yet. I'm not solving this for now. So, this is an actual bonus. Feel free to answer it on your own pace. Alright, for number 11, 15 PS to microseconds. So, let's say... No, this is not microseconds. Oh my goodness. This is milliseconds. So, yeah, milliseconds, microseconds, nanoseconds, and picoseconds. So from picoseconds to microseconds, of course, we're going up. What is going up? Divide. Yeah, divide. Okay, but still, how we enumerate the number of zeros is still very important. We don't disregard that method, otherwise our solution would be screwed. So we enumerate the zeros, we count from up to down, from the very topmost to the very bottom, regardless if our value of if our unit is input or output. So milliseconds. So 1, 2, 3, 4, 5, 6, 7, 8, 9. We have 9 zeros. And so yeah, 15 divided by how many zeros? 1, 2, 3, 4, 5, 6, 7, 8, 9 milliseconds. This is 1 billion, I think. Yeah, 1 billion milliseconds, which is, in other words, 1.5 times 10 raised to negative 8. Here you go. Okay, for number 13. KM. So this time we have a problem that involves square. This is quite a different problem. The methods would still be the same in a particular sense. So at the table we have KM, HM, DM, capital DM, M, small letter dm, CM, MM. But actually no, we don't need these, we only need kilometers to meters. By the way, why didn't I write square in meters? Alright, anyways. Kilometers to hectometers, 1, 2, 3. We have 3 zeros. So from 1 kilometer, we look for, hang on. Let's put this aside for a while. 1 kilometer is equal to 1,000 meters, right? This is something that we generally know. 1 km is equal to 1,000 meters. So in that particular sense, let's use the long cut method for now for this particular problem. So 1 km squared, 1,000 meters squared, 1,000 meters squared over 1 km squared. Okay, so there, 1,000 meter squared over 1 km squared. Cancel the units. 1000 times 1 is still 1000, literally. I'm not sure why we still have to execute these solution processes when obviously it's already obvious that 1 km squared is already 1000 meters squared. What what was only different compared to the ordinary is that we have squared. We have an exponent that's greater than 1 in our measurements. So let's move to number 14. We still have the same meter, centimeter. I'm so sorry. We still have decimeter there and centimeter. So their distance is 2 zeros. From 2 zeros, we get 1 m raised to 2 over 1, 100 cm raised to 2 over 1 m raised to 2, like that. And yeah, we get 1 cm raised to 2. That's our final answer. Let's move to number 15. 1 kilometer squared, 2 millimeters squared, km squared, hm squared, capital dm squared, m squared, small letter dm squared, cm squared, mm squared. Okay, how many zeros? 1, 2, 3, 4, 5, 6. 6 zeros. So 1 km squared over 1 times 1, 2, 3, 4, 5, 6 meters squared over 1 km squared. 1 million m raised to 2. I'm sorry. This is supposed to be millimeters. Why did I just write a single m? Alright. This is the final answer. Let's move on to number 16. Number 16, meter cube. This time we have cube. So what's the difference with the usual ordinary computation? Nothing. Nothing's actually different. We just have a different exponent. That's the only difference. We still have to copy the exponents, of course. Alright. So meter, decimeter, centimeter. So their distance is 2. That looks more like a Z. 2 zeros. 2 zeros. 1 m raised to 3 over 1 times 100 cm raised to 3 over 1 m raised to 3. Cancel these values. We get 100 centimeter cube. Okay. Let's move to number 17. 1 meter cube to millimeter cube. So from meters, decimeter, centimeter, millimeter. 1, 2, 3. Total of 3 zeros. So 1 m raised to 3 over 1 times 1000 millimeter raised to 3 over 1 meter raised to 3. 1000 millimeter raised to 3. This is the final answer, I think. Hang on. Yeah, this is the final answer. Okay, for number 18, this time, as you can see, this is a new problem. From centimeter to milliliter, we're converting a specific value of a specific unit to another value that's also of a different unit. So please do take note of this. 1 centimeter cube or cubic centimeter is equal to 1 cc. I'm just not sure what cc meant. I just know the abbreviation, but yeah, please feel free to browse what cc means in the context of metric unit conversion. Anyways, 1 cc is equal to 1 ml. So obviously from this note, cubic centimeter and ml, and they're both 1, that means we still have we have the answer of 200 ml. Nothing actually changed. But yeah, please do take note of this. It will come in handy in the problems in the next page. So yeah, let's just copy paste this. Alright, let's move to number 19. So from kilometer cube or cubic kilometer to liters, first, since you have kilometers, we should convert it to cubic centimeters, right? And so we could convert it to ml, and later on we can convert it to liters. So this looks like a wise strategy. So let's start. Km, hm, don't forget the cube, by the way. dm cube, m cube, dm cube, cm cube. So 1, 2, 3, 4, 5. We have 5 zeros. So from 1 km cube over 1 times 1, then I'm sorry, this is 100,000. Cubic centimeters over 1 km cube or cubic kilometers. So cancel those values, we get 100,000 cm cube. Now that we have the cm cube, we convert it to ml. So this is also equal to 100,000 ml. So this time we convert it to liters. So from deciliter, liter, deciliter, centiliter, milliliter. Okay, so from L, 1, 2, 3, we have 3 zeros. So 100,000 ml over 1 times 1,000 liters over 100,000 ml also. So we cancel out and we get 1,000 liters. This is the final answer. So yeah, the computation is pretty long, but yeah, it's worth it as long as your solution is correct and flawlessly executed. Let's move on to number 20. I suppose that this is the last problem. Yeah, this is the last practice question. 100 kilometers per hour to meters per second. So this is also a different kind of problem. Let me show you the process. By the way, the process that is going to be done here is also similar to a topic that I'll be introducing in the next videos involving something in pre-calculus. Specifically, I think it's in the lesson of finding angular and linear velocity given three specific formulas and converting the final answer in specific units, just like this. Um, those kinds of problems would be harder, of course. Um, this will already serve as a tutorial um, for solving those problems in the future. So 100 kilometer per hour. Let's write them this way. So 100 kilometer per 1 hour. We do acknowledge that um, 1 km is equal to 1,000 meters, and 1 hour is equal to 60 minutes, which is in seconds equal to 60 times 60, which is 3,060 seconds. So with that in mind, just copy this one again over here, multiply them with the values, since 1 hour is equal to 3,060 seconds. We're looking for our final answer in seconds, so we write them this way: 3,060. Actually, no. Seconds should be in the denominator, and the r should be at the numerator, so this and this would cancel. And so for the meters, from kilometers to meters, we put the kilometer at the denominator for these two to cancel, and we need 1,000 meters at the numerator. Alright, so cancel the unwanted values, the former ones, and bring in the new ones. 100 times 1,000 would be, we just add a zero, so I think it's 100,000, and it would be over 3,000. I'm so sorry. 60 times 60 is not 3,060, it's 3,600. I've been very wrong all along. But yeah, pardon me about that. Pardon me in that regard. So yeah, this is our unsimplified improper fraction. Simplify it, we get 250,000 over 9, which is not an appropriate answer. Again, we shouldn't write our answer in fraction form, so we get 27.8 meter per second. This is the final answer. Okay, we covered quite a lot, 20 questions in one video. I can assure you that these answers are correct. I hope this video helped you in your study about the metric unit conversion. Thank you for watching this video.